Good morning, everyone. I'm Wei-Sen. Sorry, I cannot be with you today. However, with this golden opportunity, I want to share some progress in Taiwan about how to use the big data for emergency response. My name is Wei-Sen. I'm the Secretary General of the National Science and Technology Center for Disaster Reduction. As I receive this topic, I review my career working in emergency response. I remember I started joining emergency response since the year 2004. At that time when I joined emergency response, I think it's the period we base on experience. What does it mean based on experience? I think is the emergency responder lead the whole operation. What tool we have, especially major tool we have in the 2004, I think, paper map. And we receive a lot of message from radio or fax. And what kind of action we took at that time? Evacuation, search and rescue. But most of the action were taken during or afterwards the disaster happened. And what kind of information we could have, especially talk about information source, about 911, receive a lot of calls, fax, and news reports. And other stakeholders in our society were limited to join the operation. So at that time, we always operation based on experience. But in Taiwan, we suffered a major earthquake in 1999. So since 1999, we initiated a serious national program focused on disaster risk reduction. So gradually, we want to enhance risk understanding. But I think the major change is data make management different. How I say that? Because when we had more output from science and technology, I realized based on my career in Taiwan, we entered second phase. It was science-based. At that time, who will join emergency operation? Besides emergency responder, we also have the appearance of the scientists. And we have some new tool to help us to look at what was happening outside. During the emergency operation, we use more digital risk map, try to understand distribution of potential risk. And we also use a lot of scenario to tell us like what should we do to prevent kind of the risk happening or give scenario for planning. What kind of action based on science? Of course, early warning, especially. I will give some example later during my second talks, how to use early warning to warn people about upcoming risk. Or we can conduct a lot of evacuation to help people away from risk. And the most important thing, all behavior we take will before the typhoon, not just during or afterwards. Because we know if we can do something in advance, actually we are lowering the risk. So deployment of some personnel and equipment are good direction for us to lower the risk. And information source, data. Now at the science base, we have a lot of the structured data, like observed data from all kind of the sensors, like rain gauge data, seismometer. They provide a lot of data. And based on the data, we can use numerical model to give a lot of output. And because it's entered the information age, internet help us to collect or disseminate a lot of information to users, to responders, to anyone we think we can reach. And nowadays, especially demands on intelligence for impact assessment. During my talk, I especially emphasize impact assessment. As a disaster manager, we are not able to predict disaster itself because there are so many variables that could affect the impact of any kind of disaster. However, we should do some impact assessment to tell possible impact, then we can take some action. So right now, current phrase in Taiwan we think is information based, especially information intelligence. I borrowed this term from the commercial sector because we think we should use information to produce some intelligence, maybe for decision maker or for the local people. And who will join emergency response together? Besides emergency responder, scientists, general public also play a certain role when we have emergency case. New tool, especially social media and real-time data, because we had more uh, thing connected internet. Of course, I think in few years we will have a lot of Internet of Things help us to collect data. But nowadays, we through the social media, we are able to collect lots of non-structured data that could help us to understand the characteristic of each event and the action beyond the traditional one. Right now, we focus on risk communication impact, impact-based preparedness. Through this, we can do some preparedness to help people away from possible losses or casualty. And information source right now, live video, social media are another two new sources that help us to understand disaster. So right now, all stakeholders are active participation. So from limited participation, invited participation to active participation, that means dramatic change in our society in Taiwan when we have any kind of disaster. So because this topic we are talking about big data. So big data we should match with the open data together. Especially when we use the two kind of data, we must be aware of different things that several problems, several challenges we should focus in advance. First, consider about volume. We must consider overwhelming amount of data sets. That the problem is how to identify relationship for integration, especially some information from social media and press. We have experienced several years ago, even now, whenever we have a big disaster like earthquake or typhoon, we can collect maybe 10,000 reports from social media. But based on our experience, the 10,000 reports on social media or from the internet, maybe only 100 or even less of them are available to us. All the other could be duplication or incorrect message. Second thing, consider about velocity. During the urgent moment, pop-up situation and information could hamper decision-making process. So how to have the systematic way to collect information through internet and smart device, that is also important thing. Once upon a time in 2004, whenever we had a big case, maybe we will get response from the site like 30 minutes later. But nowadays, in some cases, if power and telecommunication are in good situation, we might get the first response in about 5 minutes. So velocity is more faster than we experienced before. Another thing is about virality. Do remember, when we try to understand impact from disaster, we also have to consider different and diverse data sets. That is the fundamental thing for disaster manager to do. So we must have a plan before, during, and after disaster. How we make the best use of variety kind of data. Last thing about verification. I mentioned lots of duplication, even rumor could occupy space of internet to send information. So how to trace and clarify some rumors, sometimes also the big job for the disaster manager. My experience, 2 years ago, amid one typhoon, suddenly on the internet, two historical photos were circulated, and people said is the current situation. The water almost over the levees. Then they want people to pay attention to. However, when we saw the picture, immediately we know that is 5 years old picture. How we clarify kind of rumor? Immediately, my office, we have teamwork. We collect all the reading from the river level gauge in real-time video and call for a press conference, show the picture and show the current situation, real-time situation. Immediately, the rumor disappeared. So that is another challenge for us about verification. Who are target users to use the big data and open data? Nowadays, another point we should emphasize using big data for emergency response, a kind of end-to-end system. What is end-to-end system? From data end to decision maker, from data end to local resident, from data end to people work for NGO. We can identify so many end-to-end systems, but in general, we should understand what those big data set could be applied for. For NGO, maybe risk communication is a good direction. They can work on big data to tell people the possible risk and where to evacuate. Second thing, tell about the route to shelter. And about emergency operation, later I will also emphasize this part, common operating picture, which is an important part for emergency responder at a different site, different location that can work together. Another one is about risk assessment. We must have a kind of open data and big data to help risk identification. Other thing like urban planning and land use, we need kind of big data, especially consider about kind of the environmental change that could have impact on disaster risk management. Another is new topic. Actually, I will talk in my second talk about business continuity plan. When we consider, we try to motivate the whole society for a better disaster risk management, we should consider private sector as the part of our society. So we need the business sector to understand how to use the BCP to better protect employee, asset, and profit. Another thing about the drill. In Taiwan, every year we will use the big data to generate some scenario for drill. On September 21st, in 1999, a big earthquake happened. Another part to use open data and big data is to make plan, especially consider before, during, and after disaster. Give you a hint why Taiwan entered information-based emergency management. It was because of Typhoon Morocco. Typhoon Morocco is number 8 typhoon in 2009, but it triggered a process to integrate information for emergency management. You know, nowadays we talk about some new normal, some climate change, some extreme weather events. Typhoon Morocco is the typical extreme weather event. Let me give you some background of Typhoon Morocco. Before Typhoon Morocco, Taiwan, we are facing the problem of drought. We almost to operated emergency operation center for drought. So at the beginning, when we realized typhoon was coming toward to Taiwan, we were a little bit happy. Because you see, at the first 2 days, from August 5th to August 6th to August 7th, the typhoon was moving at a fast pace. That would mean good. They just have some downpour, give us some fresh water, then it will leave. But however, when the typhoon was approaching to Taiwan, it slowed down and caused tremendous losses and casualty to Taiwan. These are the numbers. Totally, almost 700 people die. You see, this is the chart of precipitation during the whole event. In the Alishan mountain area, it received almost 3,000 millimeters rain in 3 days. 3,000 millimeter rain in 3 days. So this event has broke a lot of record in Taiwan about precipitation. You see, this is kind of overwhelming situation we have. Along the low-lying area of the west coast, we had a lot of cases reported about urban flood. However, the most devastation were in mountainous area. Because it was in mountainous area, no traffic, no telecommunication, no power, so it had formed a lot of isolated area. In this area, we had a problem to communicate with them for a couple of days. So that caused a lot of panic to people in Taiwan. A lot of people were worrying about their loved ones living in mountainous area. So when we review what happened after the Typhoon Morocco, we think information, especially making use of data and information, are very important steps. Especially we identify 3 areas that we should work on. First, too much or too little information at the emergency operation period of time. What means too much? Let me back to this one. Urban flood area. Of course, in this area, people suffer floods, and because the power and telecommunication were still on, so people were able to make call or post some information on the internet to tell their situation. However, in mountainous area, because of interruption to power and telecommunication, we didn't have any idea about their situation. So how to have more channel to acquire useful information? We need multiple sources. And especially we need a system to integrate information. I will show our system later. Because without a good system of systems, we just have the segmental information. So commanding officer was not able to make good decision because the fragmental information. Because of fragmental information, that means we didn't have the common operating picture to coordinate action. What does mean common operating picture? Common operating picture means we speak on same page. Based on the same information, we can have teamwork. We can have good coordination. So right now, we emphasize use a lot of potential risk map for planning. Especially, we emphasize use the real-time video plus GIS information to fill the gap between the central and local government to have a better risk communication than before. Another one is situation map for operation. We have to tell what is happening outside to tell the situation for decision maker to make a good decision. Another one, how to help good and timely operation. So we need a team, we need evidence-based decision, and we need a digital emergency preparedness. So we had to share information. So after Typhoon Morocco, a big progress we had made in Taiwan is on information sharing and exchange. This is how we integrate information. I mentioned first one. At that time, we don't have information integration at a very good condition. So we try to integrate input from different government agency into one integrated system. So people don't have to visit several websites. They can have integrated information on one web page. Second things, traditionally, emergency responder just offer a lot of paper reports. But if we want to transform those texts on situation map, we need a lot of spatial description. So were seeking close collaboration with the emergency responder at the central and local level and ask them, wherever they have kind of description, please add some spatial description so we can help identify possible area and give a holistic picture to everyone in the emergency operating center. So integration big data set based on demand is very important thing. Right now, over 20 more regulating governments share, I think the number right now already over 200. They share us a lot of the big data, real-time data for information integration. In the mechanism right now, we are using to maintain the data sharing. First, we use a lot of clouds. The clouds define who are our target user. So we use the public cloud and private cloud. Just consider about the user group. For the general public, we'll use a public cloud to share information. For some confidential information, we'll use a private cloud to ensure the safety of the data and to ensure efficiency of data transmission. All the mechanism is service-oriented architecture. That's the major challenge to have data integration. Two things. First, mutual trust. Why the 20 more government agencies have to share information with my office? So we need the time to build up partnership to make them know don't be afraid of openness. And very important thing, we need a top-down determination. In 2009, both the Premier and Vice Premier supported the information sharing with NCDR, with my office. So this is why in very short period of time, we can able to collect a lot of information. So what's the major function for the big data or open data to cover? First, information intelligence. I have to highlight this item very much, especially from how we organize data. We have 100 or 200 data set, how we can organize data to tell a story. And based on the data shown on the map, how we offer a good analysis, how we storage the data. And this is a very important part, how we present the data in very clear and understandable way. But what kind of basic big data we might have? Physical, social vulnerabilities, historical event, numerical model, and observation. So we should build out a good archive to store all kind of the data set. And use how to use the big data and open data archive, cloud system. Very important thing about data format. Without a good data format, we cannot exchange data in very efficient way and exchange protocol. In Taiwan, we spent a couple years to standardize protocol for the data exchange and also about data format. From the historical development, there are several data formats, especially for GIS. So during NCDR, working with other government to integrate data, we also work on the two things. Another one, consider who are target user, government, research institutes, NGO, NPO, media, social media, even citizen are our target user. So this is how we integrate data. 200 more big data sets is fundamental thing. Maybe live data or monitor data or the history. But most important thing, from created database and become information. But most important thing, through the discussion, through our experience, we must make it into action. Maybe evacuation, maybe deployment, or some response. So in our data, actually, we include several big data sets. First, no matter about administrative boundary, road, river, dam or dike, location, about the route of highway, and potential risk map, and a lot of aerial photos, satellite image stored in our system, kind of basic layer to show the situation. Second thing, a lot of real-time or near real-time monitoring data. So we have the precipitation data, river level data, dam operation tide, or even radar image. All the information come to my office, then we integrate into different systems and make use of it. Another thing is some data produced by scientific model, like the flood risk map, slow land risk map, rainfall forecast, some dynamic model for typhoon, even some statistical model. So we must also include a lot of scientific model to tell a good story. Number four, to collect a lot of situation, like where we have flood, we have power outage, where we have shelter, and about the traffic or road closure. So through the different topics, we collect different information to show our system. This is the goal why we need so many data and have to teamwork with the emergency responder. This is a case about typhoon. For typhoon, principally have problem of strong winds or torrential rain, but based on the two category, wind damage, storm surge, flood, landslide, mudslide are possible impact no matter to urban area or mountainous area. But we want to look at the four items here: when, where, scale, and scope of impact. We pass information to emergency responders so they can take action. So is we call it kind of from scenario-based science and technology. Through information dissemination, we help emergency response. So this is how we function in the Central Emergency Operating Center in my office building. I hope someday if you have a chance to visit my office, I can show you how we operate here. So we try to integrate all information and bring forward action, work together. And how to tell a good story. Of course, from overall concept, from this one, people can understand how the typhoon will impact Taiwan or Philippines based on the prediction from 6 countries. And we have the main window to tell about the radar image, rain cloud image. So we combine them together, we can understand about the current situation. Where is the rain band? For this one, we can find clear this is the rain band, this is another rain band. Based on the location of rain band, we can propose some remind to local government or central government. Bookmark, because we don't want our user always try to overlap a lot of the GIS layers. So we prepare a lot of bookmark to help them to have the quick look about situation outside. Another one is the map control panel. You can zoom in or zoom out or measure some area on the map. Another one about the timeline, because we might check the information after disaster. So all information on our system, we have time-dependent variable. So even after typhoon, we can trace the time and understand about the impact. Another is about image comparison. So we collect a lot of the basic image. By using image comparison, we can compare before and after disaster. This is our current system. We want to enhance the risk understanding and through giving a good common operating picture. So our web page design in very easy and understandable principle. First, we must offer one clear pictures. These pictures must overlap information from several resources. Like this one, we at least integrate 3 layers on one page together. Second thing, we must provide some short description for emergency responder to understand the story of this picture and also show some real-time data to match this story. Like see here, we also offer some bookmark for the user to click and find the answer they want. Talking about open data, to offer a standardized protocol in Taiwan, also the big progress to help us to disseminate warning to a lot of end users. Since 2013, we introduced Common Alerting Protocol. It's kind of the international standardized format to package all the alert, all the warning issued by government sector or some private sector. We put on our website and we use push mechanism to share with app developer or the private sector. Currently, we had 600 more end users subscribe the kind of cap format open data for further application. And one of our big users is Google. Since 2003, we have a collaboration with Google. We share all this open data on the Google Crisis Map. And Google will also use the Google Public Alert to warn their users to disseminate information. The numbers are here. In 2014, 2015, and 2016, you see millions of users ever receive information from Google services. You might ask why we have to collaborate with Google. Very easy. First, no government agency is able to maintain a big bandwidth to accommodate many users at the time, especially when we have the typhoon. However, Google is capable of doing this. Second things, we will push the information to user's cell phone. So we got a channel to reach the user by last mile connection through Google. Third thing, we don't have to educate people how to use Google Map because everyone knows. Think about we save time, save bandwidth about last mile. So it kind of win-win situation to have public-private partnership on enhancing information coverage. Even in Taiwan, we had so many 7-Elevens. Actually, in whole Taiwan, we have the 10,000 more 7-Eleven, 10,000 more the convenience store, 50% 7-Eleven. So 7-Eleven had kind of contract with the Central Weather Bureau. On the cashier screen, they will show typhoon information. Also win-win situation because right beside the cashier, they can sell umbrella raincoat. They provide good information to customer, also create a business opportunity for 7-Eleven. Another thing, big threat to Taiwan, I think you might know we have been attacked by the big earthquake in February this year. So the policy framework for large-scale earthquake is another big challenge to people in Taiwan. So through studying a lot of data, actually we have the 3 priorities to think about how we face a large-scale earthquake. First, we want to enhance seismic capacity for all the existing building. This is priority 1. Priority 2, to ensure citizen safety and support, like evacuation and sheltering. The third thing is the functional continuity, no matter for government and for business. So scientific support is very fundamental thing. We need scenario and impact assessment. So for the old and existing building, we need retrofit. To support citizens, we need early warning system and massive demand during times of emergency, like the food, like the medical care, even like the space to operate operating centers. Another thing is to have the business continuity plan and management in both the public and private sector. Then we need the practical implementation for all kind of project here. So we integrate a lot of big data in Taiwan. So we bring out the one system. We call it Taiwan Earthquake Impact Research and Information Application. On the platform, we use all the information here to offer impact assessment before and after earthquake. Fundamental thing we should understand about the impact, what is kind of impact, and how we find solution through the data we collected. Like about evacuation, we might need information about bridges, road, highway, freeway, buildings, school buildings, fire protection, and a hospital. So before we can identify solution for evacuation in our database, we should collect a lot of vulnerability or situation of the green item shown here. Likewise for the medical service, search and rescue, and life supporting function. And another thing, we should also have a lot of the real-time reading for strong ground motion, ground failure, even understand possibility of tsunami. So we might have kind of scenario in advance to know how we analyze impact after earthquake. To have big data, this is one example. We want to know all the location of building in Taiwan and make a density map of building distribution. So we collect data, especially text data, from the local government. So we also collect sensor data about population and the residency. And we also collect data about the pipeline network of water, power, and natural gas. And also understand the location of the bridges and highway. So from the map, through our grid, each grid size is 500 meter by 500 meters, so we had a better look at about impact from earthquake. As I mentioned, so many basic data set help us to bring out scenario and impact assessment like bridges, highway, power, water, hydro utility, natural gas, pipeline, and the pipeline in specific area like industrial park. What is the grid master? In each grid, 500 meters by 500 meters, we include like a lot of physical vulnerability and social vulnerability. To understand if earthquake happen, we input any ground motion, we can estimate liquefaction, landslide, casualty, building damage, even interruption to road and traffic, lifeline system, and some infrastructure. So total number of grid right now we are using just for case in Taiwan is 13,000 more grid. We also try to understand the population distribution, so we collect the census data to understand population distribution to give a good look at if earthquake happen in dense populated area, how we have a tailor-made process to lower the risk. Another one is about provide some scenario simulation for earthquake drill. This is the typical one. We assume one fault might move, and through our system, we can produce some scenario information for local government or central government to conduct exercise. And from the basic data I explained, we can understand the construction material in any specific area, like wood, steel, light steel. So based on this, we can estimate, we can understand the building built before 1962 without seismic design core, that is, we think is vulnerable to strong ground shaking. So we can easily highlight the area could suffer severe damage after big earthquake. And we also give some scenario. For example, this is the fault line passing a Taipei Basin area. Based on one scenario, we can identify intensity 5, 6, or 7. And based on the basic requirement, we can tell about the casualty, about evacuation demand, water, possible water interruptions, and power interruptions. This is how we use the grid method to estimate about the damage. About population, right now we also collaborate with the telephone company to use the telephone number to estimate about population distribution. This case, New Taipei City, and Keelung City, the total population is about 7 million, equal almost about one-third about the whole population in Taiwan. From the grid size of 1 kilometer by 1 kilometer, we can have kind of the population distribution dynamically 24 hours a day. This is the weekday pattern, and this is weekend pattern. Through these two, we can understand how we have the kind of idea people might move from time to time, from daytime to nighttime, and where are the more people concentrate on. So this is a good comparison about how we decide population distribution through kind of big data from private sector. And another important thing right now, I emphasize we use social media. So in recent year, we have a colleague work on the data crowding platform. We try to collect a lot of data from social media and help us to understand about a lot of situation. This is a case actually contributed by my colleague, Dr. Liu. It's a case study of the 2015 during a Typhoon Sudire. We can find the volume of the post on the internet. They might talk about the different issue, but one of this they are talking about Wulai, where received severe damage. That is showing the trend because a lot of people worrying about the Wulai, so you see the rising trend on this line. And we also match this one beside information, situation, and precipitation. We can principally tell when a possible disaster could hit at a certain area. See, we collect the information from different websites. So this is how we use the social media to estimate a developing situation. So these are the future case we might use the big data to solve. First, some scenario-based disaster risk management for large-scale compound disaster. Especially right now, we consider a lot of black swan events, especially when we see Hurricane Katrina, Typhoon Maraco, and the Great East Japan earthquake and tsunami. We realize we have to face a lot of unprecedented and complicated impact. So based on a continuously developing situation, how we use the big data, how we use the science and technology to estimate the demand for disaster management is one thing I think we can work together, especially we need a tool to build up scenario for planning and drill. We need design information system to provide situation awareness, especially in consideration of large-scale compound disaster, and to understand and study evolutionary characteristics of compound disaster. Another one is about climate change adaptation with disaster risk reduction. In my office, we will also consider these two things together, especially for the water resource management in Taiwan. How to have the balance management in Taiwan in consider several direct impact like high temperature, sea level rise, rainfall distribution change, more extreme weather event, even kind of the typhoon and storm surge change. Another big thing I think all disaster managers should remember about the social vulnerability. So in last few years, some of my colleagues are working on some social factor, including population density and structure, education income, economic activity, past event and perception, social support and insurance. Try to find some solution based on a problem we identify here, like rapid urbanization, land use the problem, aging society, vulnerability of indigenous tribe. That's the thing we should consider about. And even possible product to deliver kind of the we call it the SVI, Social Economic Vulnerability Index, to tell about where we should have the better policy on. Another thing about impact to critical infrastructure. We want to use our big data to identify possible impact to critical infrastructure. There are two cases in Taiwan. The first one, in 1999 Chichi earthquake. The earthquake destroyed one major power transformer station in central part of Taiwan, caused a island-wide blackout event. Likewise, this is what happened in 2004 after Typhoon Ariel. Though we had a lot of water, but dirty water, so we had a problem of water supply. This is something we have to face. So this is we call it critical infrastructure exposed to nature hazard. So to conclude my first talk, I want to emphasize in face of diversity of natural disaster, we should consider N to one, one to many. What is it N to one? N kind of data source to one unified operation bodies. Then to provide product to many diverse users. First, what is N kind of data sources? Could like the data from sensors, monitoring data, numerical input, physical or statistic data. Then also include social data, geo data, historical data, but we must foresee the future trend, a lot of non-structured data, especially posts on Facebook, posts on Instagram, posts on other social media. One unified body, maybe EOC at a central or local government, they are able to collect information, and based on the target user here, we offer tailor-made product to citizen, decision maker, NGO. Even we should consider channel to reach user. I will emphasize later about how we use the multiple channel to reach end user. So this is my last slide for the first talk. Why we need big data for emergency response? I think now is the time we must bring data to actions. Now we talk about the issue about the data. Of course, 100%. It's based on science and technology. Since we have science and technology, we produce a lot of report. One serious problem we should consider how we can enhance understanding in people's, especially local people or decision maker. So we need a process of transformation to make those scientific report into understandable knowledge. Only understandable knowledge is not good enough. We need the people good at interpretation to tell a good story to change people's mindset. The process is enhance understanding risk. So since we change people's mind, actually we enhance their perception. At any time of emergency response, they are able to take action. If we match the four process actually exactly the same highlighted in Sendai framework for disaster risk reduction, investment in transformation, understanding to help interpretation, governments through precipitation. But the most important thing, we understand importance of disaster preparedness. In each phase, actually, we need involvement from different stakeholders. For the transformation from science and technology to understandable knowledge, we need government, we need a researcher, a lot of here. So it's the good case of risk communication. Through interpretation, it's good we can enroot cultural DRR in different people's mindsets. And kind of the precipitation governance is the life cycle of disaster risk reduction. Thank you very much for your time to have my first presentation. Later, I will have second one. Thank you very much.